Good afternoon. Thanks for joining. I hope you've been enjoying the summit so far. Let's start with a show of hands. How many of you are developers that love networking? All right, quite a few. That's all right. How many of you are developers that would love to have networking simplified for you? All right, that's better. For the administrators here, cloud admins, network admins, security admins, how many of you are administrators that want to have connectivity, security, and visibility made easier for you? That's great. You're at the right place. And that is the whole purpose of Amazon VPC Lattice, to simplify application layer networking and make it easier for you administrators and developers. My name is Yashar. I'm a solutions architect with AWS. I'm also joined by Yogita, engineering manager at Direct Line Group, who will share some of the learnings and experience with designing and implementing VPC Lattice in production. So we heard from you developers that you don't like to get involved in networking, dealing with IP addresses, route tables, network troubleshooting. With VPC Lattice, we want you developers to build your applications fast and simplify networking for you so you don't have to deal with underlying networking connectivity. We want you to build your applications wherever it makes sense to you, in different VPCs, across different accounts, on different compute types, and don't have to think about how to connect these networking elements together. At the same time, you want your applications to be secure, most probably by implementing zero trust architecture, which basically is a security model that access to data is based on the trustworthiness of the identity requesting the data, and not just their network location. From visibility perspective, we want to provide you with not only application layer logs and metrics, but also the underlying networking metrics and logs so you can use those for application optimization, visibility, and troubleshooting. For you administrators, we want to address a few common challenges. We want you to be able to centrally enforce your access controls and authorizations for applications and be able to audit your organization's security posture, but in a manner that you're not slowing down the developers. And again, making connectivity, security, and visibility easier for you. In particular to connectivity, we want to tackle a few common challenges. Cross-account connectivity, connecting overlapping networks, and IPv4, IPv6 connectivity. So in this session, we will go through an overview of Amazon VPC Lattice. I will touch on a few newer features that were announced end of last year. We will then examine some common questions and common architecture patterns with VPC Lattice. I will then hand over to Yogita to speak about how they did it in Direct Line. And at the end, we will see how you can get started and get hands-on. The building blocks of VPC Lattice are comprised of 4 key components: services, service network, auth policies, and service directory. Now let's go through these. So what is a service in VPC Lattice? A service is a logical abstraction of what your application is running on and how you're exposing it. The entry point to the service is specified by a DNS name. So in this example, app1.example.com is a service in VPC Lattice, and that's just a logical front end. It consists of listeners, rules, and target groups. So the listener is the protocol and port. It can be HTTP, HTTPS, or gRPC and the port number. The rules are conditions under which traffic is directed or sent to a specific target group. Traffic routing decision could be based on request path, request header names and values, or request method. So for example, if a traffic comes in for app1.example.com on HTTPS port 443/path1, it'll be sent to target group 1. If it comes with specific request header names and values, it'll be sent to another target group. Or if it comes with a specific request method like get, put, you can send it to another target group. You can also have a default catch-all rule that would send the traffic to a default target group. For example, if something comes for HTTPS port 443, regardless of what the traffic attribute is, it'll be sent to that target group. And target groups are a collection of targets. The supported targets are EC2 instances, IP addresses, Lambda functions, and application load balancers. For integration with Kubernetes pods, there is a controller that will show up as an IP address. And for your ECS tasks, Elastic Container Services tasks, you will use your application load balancer as your target. Now, this gives you a lot of flexibility because the service is specified by a single service name, regardless of what is behind it as a target. So developers would have a lot of flexibility in choosing their backend target. Now, when you define a service, you would also be able to give weight to your targets. So in this example, if a traffic comes for /path1, 90% of that could be sent to target group 1, and another 10% could trigger a Lambda function in target group 2. Again, this is very useful because it helps you with your blue-green deployment. The client still hits the service on its service name, it hasn't changed, but at the back end, you would be able to switch to another target. Service network. Service network is another logical abstraction. It's a grouping mechanism for consumers and providers. So basically, it provides connectivity between the services and the client VPCs that require access to those services. So you create a service network, you put services in it, and then you associate that service network with your consumer VPCs. And then on top of that, you would be able to apply common authorization and access policies. Just because the VPCs and services are connected through the service network, it doesn't mean that everything can talk to everything. You still need to allow that through authorization policies. You specify who can access what. And authorization policies are IAM resource policies. So if you're familiar with other IAM resource policies, one example of that would be S3 bucket policy. In your S3 bucket policy, you specify who, the principal, can take what actions on this resource, which is the S3 bucket and the objects in that bucket. Similarly, with VPC Lattice, your resources are your services. And this authorization policy could be applied on service network, and it could be applied on individual services. And if you do that, the effect would be the least privilege, the intersection of those two policies. So for example, if the service network auth policy allows your traffic and your service also, or the authorization policy applied on the service would also allow that traffic, then your client VPC would have access to the service. If the service network auth policy allows your traffic, but the one that applied on the service level does not, then you won't be able to access the service. So here's an example of an auth policy for service network. And if you think defense in depth or a layered security approach, this is where you apply your coarse-grained policies, your guardrails. Because the policy applied at this level would affect access to all the services connected to this service network. So you want something effective, but also easy to troubleshoot. So in this example, I'm allowing access to all the services associated with this service network, provided that the traffic is within your organization. So I'm using one of those global AWS conditions. So at least you're validating that the traffic is from you. And then on the service side, you can be more complex, you can be more detailed, apply fine-grained access policies. You can be very detailed, can specify who the caller should be, who the principal is, where the traffic comes from, which source VPC, which service network, and what other attributes this HTTP or HTTP request should have. Query strings, method, header names and values. So this is very, very detailed. And then finally, service directory. It is a list of all the services that are either created in that account or are shared with that account through Resource Access Manager. It's a simple yet effective tool because developers can come here and get the service name, and administrators can have a look at this list and see what services this account has potentially access to, because the access still needs to be allowed by your auth policies. So who does what usually? Usually administrators would create a service network, would define the access policy on that service network, and then would associate that service network with your consumer VPCs. Then developers would define the service, would apply traffic management and authorization policies for the service, and they may or may not be able to associate that service to the service network, i.e. exposing it to the rest of the network or organization. That is something that depends on your security or governance model. Do you want developers to have that ability to expose that service to the rest of the network and organization, or the administrators should be in charge of that? As you will hear from Yogita, in Direct Line Group, they decided that it is a task of an administrator. Now, here's an example of a bunch of VPCs and services. So you can see that there are different applications across multiple VPCs. The very first step is to define your services. So blueberry, kale, tomato, carrot, cucumber, cherry, apple, and pineapple are defined as VPC Lattice services. And as you define them, they would appear in the service directory. The next step is to create a service network. And finally, you associate the services with the service network and with the consumer VPCs. Now, in this example, you see that, for example, raspberry and banana are two applications that require access to blueberry, cherry, and tomato. They will call them, but no other applications call them back. And that's why they have not been defined as a service in VPC Lattice. Whereas on the other side, in VPC2, we've got two other applications, carrot and cucumber, that have dependency calling tomato and kale. So they are associated with a separate service network and access those applications through that separate service network. Now, the client VPCs and services associated with a service network can communicate with all the services in that service network. You notice that there is no application network load balancer, there is no VPC peering, there is no transit gateway. VPC Lattice would handle all that functionalities for you. You also notice that Tomato as a service is associated with multiple service networks. So you would be able to associate your services with multiple service networks. So to wrap up, VPC Lattice helps you with connectivity, cross-account, cross-VPC. It is integrated with Resource Access Manager, so you will share your service network and services through Resource Access Manager. I will go through an example of traffic going through VPC Lattice, but you will see that anything going to VPC Lattice and coming from VPC Lattice are from special range IP addresses, which are called linked local IP addresses, and VPC Lattice would handle that network address translation for you. Supported protocols, HTTP, HTTPS, gRPC. Request routing decisions could be based on the path, headers, method, and you would be able to give weight to your different targets. When you associate a client or a consumer VPC with your VPC Lattice, you would also be able to define inbound traffic to VPC Lattice. Just because that VPC is associated with service network, it doesn't mean that you would allow all traffic from that VPC to service network. You would still be able to control that with a security group that you apply at the point when you are associating your VPC with service network. So effectively, you're specifying which inbound traffic is allowed from that VPC. And as I mentioned, target types, IP addresses, EC2 instances, application load balancers, and Lambda functions. For integration with EKS, there's a controller. It's called AWS Gateway API Controller. It's open source, and it will show up as an IP target. And for your ECS tasks integrations, you can use your application load balancer as the target. Now let's go through some of the newer features that were announced end of last year. And of course, one of the important ones is identity header propagation. With this feature, we add metadata in the form of request header in every single request. So if you think about it, this is really powerful because it not only gives you visibility and useful for troubleshooting, you can also use all that information in your backend. It includes information such as who made the call, who was the caller, the principal, was it authenticated. If you use IAM roles anywhere, that header would have information about X509 certificate. You would see which source VPC the traffic comes from, which service network the traffic comes from. So that gives you a lot of information that you can use for troubleshooting, but also for consumption at your backend. If a Lambda function as a target receives an event from VPC Lattice, we also add all that information to the event structure. Again, who the caller was, which source VPC the traffic came from, which service network traffic came from. And again, this is really, really powerful because you can do a lot of things with that information in your Lambda function. One example would be custom authorization or request header manipulation or personalization. The other feature was customer managed permissions. What does that mean? So when you share a resource with Resource Access Manager or RAM, and in this case, it'll be your service network or services, you would also be able to define what actions that shared resource can take. So for example, I have a service network and I want to share it, but I want to share it in a way that only VPCs, only consumers to be associated with this. So I have my service network. As I want to share it with Resource Access Manager across my organization, I also point to a policy that specifies only specific principal 111 in this example, would be able to take action. And that action is associating VPCs with this service network. And again, I can be more detailed and specify VPC ID. So I can even restrict that with this customer managed permissions. Now let's go through some common questions about VPC Lattice. And of course, the first one is, how does the packet go through VPC Lattice? So you remember that a service is specified by a DNS name. Now in this example, I have two applications across different VPCs. I have an inventory application in VPC1 that wants to communicate with a billing application in VPC3. So the first thing is I would create a service for my billing application. VPC Lattice would generate a service name for me, a long name. And if you want to use your custom DNS domains, you would create an alias record for billing.myapp.com and you point it to that VPC Lattice auto-generated service name. Now my inventory application wants to reach to the billing application. It sends a name resolution request for billing.myapp.com. Route 53 replies back with an IP address in the range of 169.254/16 for IPv4 or FC00/7 for IPv6. You notice that 169.254 is not the real target. The real target is 10.0.0.7 in VPC3. And in fact, it conflicts with my source, which is also 10.0.0.7 in VPC1. But that's not a problem because it is all that connection is abstracted by VPC Lattice, and your source talks to a linked local IP address. Of course, the outbound traffic needs to be allowed by your security group. By default, security group allows all outbound traffic. But if you have some custom rules in your security group, you need to be mindful that your outbound egress needs to be towards linked local IP addresses, 169.254. So after traffic goes to VPC Lattice proxy, because obviously VPC1 knows about those IP addresses, it's been enabled for VPC Lattice. It goes through traffic validation and HTTP transaction. It needs to be allowed by service network auth policy, also needs to be allowed by the service auth policy, and then When it reaches the listener, it goes through traffic management rules. And then eventually it is sent to the target. And again, at this point, traffic comes from a linked local IP address, another 169.254. So again, you have to be mindful that your ingress security group needs to allow that traffic from a linked local IP address. But you don't need to worry about those IP addresses because there is a managed prefix list both for IPv4 and IPv6 that you can refer to those prefix lists in your security group, both for outbound and inbound. The other question is if you can have more than one service network per VPC. In other words, is it possible to connect your consumer VPC to more than one service network? And the answer to that question is no, and you don't really have to. So you remember that the services could be part of multiple service networks. So if you have a VPC, a consumer VPC that has a very specific traffic requirements, you can create a service network just for that VPC, put all the services that this consumer VPC needs access to, and then associate that service network with a VPC. So a consumer VPC doesn't have to be part of multiple service networks. Now let's go through some common architecture patterns. Now some of the challenges that VPC Lattice can help address, especially with east-west communication, service-to-service communication, is handling overlapping networks, which you saw an example of that, but also IPv4, IPv6 connectivity. So imagine that you have a bunch of applications, microservices. Some of them are built or migrated to IPv6, but some might still need to stay on IPv4. And you don't really have to migrate at the same time. You can take your time and migrate clients and services independently because VPC Lattice would handle that and brings that back into the abstraction. There is a very interesting podcast by Cables to Clouds, and my colleagues Adam and Ankit, they show a very great demo about all sorts of this connectivity. You can check this out. IPv4 to IPv4, V6 to V6, V4 to V6, V6 to V4. Now, what if you have an existing infrastructure that you've already built with Transit Gateway, and now you want to leverage VPC Lattice for HTTP and HTTPS or gRPC traffic? So it's easy. They can still coexist. You can have VPC Lattice for your HTTP, HTTPS traffic, and you can have your Transit Gateway still there for all the other applications that rely on TCP or UDP. So in this example, there is a travel application in VPC3, and I have two consumer VPCs, client VPCs, VPC1 and 2, that are connected together all through Transit Gateway. I also have a DNS record for my application, travel.myapp.com, which obviously points to the application load balancer name. Now, a consumer or an application in VPC1 wants to connect to the travel application. It sends a name resolution request for travel.myapp.com. Route 53 replies back with the IP address of the application load balancer. And through VPC routing, Transit Gateway attachment, and Transit Gateway routing, traffic hits the load balancer and goes to the target. Now you want to think about, okay, I want to leverage VPC Lattice. How do I do it? So the first step is you create a service for the travel application. The VPC Lattice service would create a service name for you. Nothing has changed at this time. It doesn't interfere with anything. Then you create a service network and you associate that service network with your VPCs. Again, nothing has changed. Traffic still goes through Transit Gateway. When you decide that you want to send your traffic through VPC Lattice, then you start with one VPC. You create a private hosted zone, and you have an alias record for travel.myapp.com pointing to the VPC Lattice service name. Now, what would happen is in VPC2, HTTP, HTTPS traffic would go through VPC Lattice, and still traffic from VPC1 goes through Transit Gateway. So you test it with one VPC, and then you move on, and you do this with other VPCs. They can coexist together, and in fact, you should keep your Transit Gateway for other applications, that work on TCP or UDP. So they can work together, and you can migrate your clients and services independently. Now, one of the popular patterns to expose applications across many VPCs is a centralized ingress model. In this architecture, you can control and manage inbound ingress traffic in that central VPC, and you don't have to have internet gateway for all those VPCs that host your application. Now, one thing you need to note here is in VPC Lattice, a connection must come from a VPC enabled for VPC Lattice. So how do you solve this for a connection that comes from outside the VPC? How do you allow external connectivity to all your services and applications from outside the VPC? The answer is you need to have a proxy function in your central VPC. That could be Nginx, Envoy, or another proxy application. You put those behind a load balancer, application load balancer, a network load balancer, and then you allow ingress or incoming traffic from outside to your application load balancer or network load balancer. Traffic is intercepted by your proxy fleet, which can run on EC2 instances or ECS Fargate tasks. And then from there, a new connection would be established to your services. So this is how you bring in external connectivity to your VPC Lattice. And then to protect that central VPC, you can put the load balancer behind a firewall. This can be AWS Network Firewall or your choice of firewall vendor with gateway load balancer. To further augment the security about this architecture, you can integrate that central VPC with AWS Shield to protect against DDoS attacks and AWS WAF to protect against application layer attacks. If you operate across multiple regions, you can use Global Accelerator, which would send the traffic to the nearest region, or if you create or configure a traffic dial, it'll send a certain percentage of that traffic to the nearest region. This blog takes you through the details of external connectivity. It's by Adam and Pablo, my colleagues. There is also a cloud formation provided in the blog that would run Fargate tasks, Nginx Fargate tasks as your proxy layer. The other architecture is a completely serverless one. So in this architecture, you don't have any internet gateway, traffic hits, or entry point is your Amazon API gateway, which triggers a Lambda function. That Lambda function acts as your proxy layer. But it should have an ENI in a VPC, which is enabled for VPC Lattice. Remember that traffic for VPC Lattice should come from one of the VPC Lattice enabled VPCs. So in this case, again, there is no internet gateway, and you can do a lot of things with that Lambda function. You can do traffic rewriting, header manipulation, so this is really, really flexible. And again, details about that, you can check it out in this blog. I will now hand over to Yogita to take us through how they did it in Direct Line Group.
Thank you, Yashar. Hi, everyone. And thank you for choosing to learn VPC Lattice with me and Yashar here. I'm Yogita Kaushik, Engineering Manager at Direct Line Group. And I'm here to talk about VPC Lattice as a journey at DLG. But before I do that, I would like to introduce to you as who we are. So Direct Line Group is a leading insurer company, and we have various brands under this group, like Direct Line, Churchill, Privilege, Green Flag. And we use AWS primarily for 3 reasons. The first one, we want hassle-free transactions for our customers, as well as we want to integrate with other insurance suites like Guidewire, MuleSoft, Willis Watson, Radar Life. We want our insurance quote policies to cost low, and that's why we use AWS. And last but not the least, we want full digital experience for our customers, and AWS help us achieve all these 3. Moving on, I would now like to share how big our AWS footprint is. So we have multiple AWS organizations and hundreds of AWS accounts. So we started our cloud migration journey about 4 to 5 years back. And the best practices which existed 4 to 5 years back are no longer the best practices. And hence, we have legacy applications as well as modernized applications. We have constantly been increasing the resources, the creation of the microservices. And as you can see, we have moved on from 2 million resources to 22 million resources in cloud. And there is always a need for the connectivity between the legacy applications and the modernized applications. And that's where we found VPC Lattice as a way to modernize our networking. So I would now like to share how things worked before we adopted VPC Lattice. So for example, if we have an account in one organization, it would then connect to its respective networking account. And if that development account needs to connect to another development account in another org, that would also connect to its respective networking account. And for making those two AWS accounts talk, we would do that through transit gateway peering. And if a third account needs to be connected, we would again put the routing table information and make the configuration working so that all the three accounts can talk to each other. This architecturally looks simple, but there is a lot of routing configuration which goes behind. So this is simple, this is working, but we wanted more. What we found was we have overlapping CIDR ranges. What we found was that we were missing granular control on the connectivity. We had complex cross-org connectivity, as well as the developers always had the dependency on the NET DevOps, a special skill set who could actually reach out, look at the IPAM tool, look at the CIDR information, and then put the routing configuration. So all these were our challenges, and we wanted to overcome. And then we did a technical assessment, a POC at DLG, where we used centralized service network. And this we built on top of transit gateway connection for our application connectivity. What we found was we were able to overcome the overlapping CIDR ranges problem. We were able to scale because when a service is existing, then multiple services can consume it. So we could increase the scalability. We improved the reusability. For example, if we have a service like a postcode lookup, that can be used by various brands under direct line. Various AWS accounts can use the same service, and we do not have to keep creating the similar service. So we improved the reusability. We also brought in this security and isolation, which was missing in the transit gateway. So if there is co-hosting in your AWS accounts, then you can have granular control on the services as to which service can talk to which service. Last but not the least, we empowered our developers so that they can choose which services they want to connect to, and remove the dependency on the platform team or the NET DevOps. Moving on, I would now like to share the high-level architecture. When we did the POC, we did the centralized service network, but when we actually implemented it, we found the distributed service network better. So this is one of the account. For example, take an example of a consumer account which wants to consume a service. It has an application running in it, and there is a service network. There is another consumer account, again, connected to a service network. And if these two accounts need to consume a service from a provider account, the way we would do it is we will have a central managed account where we would RAM share these service network. After the RAM sharing, the provider account will accept the invitation and then make the service network talk to each other. So just to illustrate with an example, this is how once the association is done between the service and the service network, the traffic will flow. All we need to do is make the association. AWS Backbone takes care of the rest. Moving on, I would now like to share the implementation and the shared responsibilities. This slide may not be new to you because Yashar already took you through the personas. The two personas which Direct Line Group adopted were the platform team and the developer. So the platform team would take the responsibility of creating the service network, as well as associating the consumer VPCs to the service network, defining the access control, RAM sharing it, association, as well as managing the service registry in the single pane of glass. So we will be doing, the platform team would be doing the heavy lifting so that developer would only be then required to do the creation of the Lattice service. They can, the second step of defining the access controls, that can be optional because network team, the platform team would already take care of the access controls. So defining of the access controls at the service level can be optional. And the third one would be for them to register the service, because once a service is available in AWS, the rest of the AWS accounts would like to know, and platform team can enable that. Moving on, this was my favorite thing, which I found with VPC Lattice, that there was nothing new to be learned. We can easily use CloudWatch log groups, which we have been using a lot with Lambdas. So everything was visible in the CloudWatch log groups, like the source IP, the target IP, the source VPC, the destination VPC, and the HTTP response code if we needed to troubleshoot whether the network is working or not, whether the service is speaking to the other service or not. So that was quite handful and easy. Lattice service registry orchestration. So once a service is created, how did the platform team achieve the orchestration? How did we trigger? How did we make the service talk to each other? And this is the orchestration we did. For example, when a new service is introduced at DLG, the platform team would then, we are right now using a semi-automated way because not many adopters are there. So we are storing it in a DynamoDB table. And in the DynamoDB table, we are kicking off the step functions. And the step functions would then go into the, assume a role in the provider account, and then RAM share the Lattice service to the consumer account. And from the consumer account, there will be an invitation which will be sent and accepted by the step functions. And once that's done, we would then associate the Lattice service to the service network to make the traffic flow. So this is how we have done the automation so that the Lattice service is associated from one AWS account to another AWS account. This is our illustration of the service mesh at DLG. And we have multiple AWS accounts, and we have one single pane of glass where we are managing the service registry, as well as we wanted more out of our service registry. We wanted consumer account, we wanted service name, service ID. So we have gone more above what VPC Lattice provides us. We want to have one single pane of glass where we can see which service is talking to which consumer account. Last but not the least, and our journey doesn't stop here, we are working with AWS in automating our service registry completely, and we are also looking to evaluate our IPv4 to IPv6 migration, which VPC Lattice supports. Thank you, everyone, for listening to us. I would now hand over to Yashar.
Thanks, Yogita. Very insightful. So, how can you get started and get hands-on? There is an online guided workshop which takes you through multiple labs. You can see firsthand how to create services, service network, and how those authorization policies would work. This is highly recommended. You can also refer to the list of VPC Lattice blogs. There are, of course, multiple other details that we were not able to go through here, and you can check those blogs here. And if you're interested in AWS Gateway API Controller and integration with Kubernetes, you can also check these blogs. With that, we thank you all. Please don't forget to fill out the session survey. We really appreciate your feedbacks and comments. Thank you. Enjoy the rest of the summit.